of Alzheimer's disease at the preclinical stage. So that preclinical stage is the clinically normal stage when people are healthy, but they are starting to show evidence of abnormal Alzheimer's disease-related biomarkers. And I'm talking a little bit about resilience and vulnerability. And the reason why I say resilience / vulnerability will become apparent as we go through the talk. But it will be, you know, there's two ways to see some of these findings and to think about some of these findings. And these questions are not yet answered. And so this is why I sort of talk about both whether some of these findings may reveal some level of resilience or some vulnerability to disease. So the first pieces of information that I will show you will start from a broader level of what it means to see sex differences in risk for Alzheimer's disease dementia. And then we will slowly start to funnel our way down to the more sort of biomarker heavy side of the talk. And so to just sort of give the 30,000 foot view, where the initial work for sex differences in Alzheimer's disease dementia really came from the epidemiological side of things. At a population level, quite a few studies many decades ago were showing that prevalence rates, so when you just capture a population at a single snapshot, how many people have dementia and are they men or are they women, there seemed to be across the board a lot of studies showing that women showed higher prevalence rates for Alzheimer's disease dementia. But there was a little bit of pushback on that because people suggested, well, prevalence rates could simply be driven by longevity, that women tend to live longer, therefore they would have higher prevalence for dementia just simply because of that. So more and more studies came out looking at incidence rates instead. So within a large population level study, following those people who start out healthy at the beginning of the study, what would be the incidence rate, so the time at which somebody progresses to dementia within that study, were women still at greater likelihood of the higher incidence rate? And so this first study I wanted to point out here on the left-hand side is one of those. It's a meta-analysis, or it's a review of multiple different cohorts that looked at incidence rates in their population level cohorts. And they found that, in fact, women did show higher rates of incidence than men for progression to Alzheimer's disease dementia. However, they found something very interesting, that women did show higher rates of incidence, but it was only really in the European studies, not necessarily the American studies down the bottom row here. And so I guess that's why I start off this slide with a little asterisk in the title, because I wanted to highlight the fact that while the population level findings are interesting and they seem to suggest that there is a sex difference in incidence rates, it's not actually across the board, and there is still some contention to some extent on the extent to which sex differences exist in the population. On the right-hand side here is a study that I did with a few other epidemiologists looking at death rates. We were interested in if we could capture, so the difference between these two studies is that on the left, this is not every single person in the entire country, but on the right here, we gathered all deaths that happened between 2006 and 2014 in Australia. And we counted how many were considered to be or coded as a death due to dementia, Alzheimer's disease dementia, whether it was primary or secondary. And we then adjusted for the age at which people died, other comorbidities like cardiovascular risk and other things that can differentiate the sexes. And we found that even after adjusting for all those things, women did seem to die more of Alzheimer's disease dementia than men, particularly over the age of 85. And that this finding, though, was not as strong as you would think. The effect was 14% more likely. So just to put that in context, that there was a sex difference there, but it was more subtle than some might think. So it's just something to bear in mind, that these sex differences do occur, and we will show more evidence for this, sex dimorphism. But just to bear in mind that the effects that we see are are not as sort of clear cut as you might think, which is important when we're talking about sex differences to the layperson, for instance, the public, when we're trying to discuss the idea, for instance, that women may be at greater risk. I think that causes a lot of fear in the public. But in fact, that these findings are more subtle than the media may portray in some cases, and it's good to keep that in mind. So there's also a lot of data out there now on genetic vulnerability, particularly in females. And when I'm referring to genetic vulnerability in this particular instance, we'll talk about genes more later on. But there does seem to be a lot of evidence that female E4 carriers in particular seem to be particularly susceptible to progression to AD dementia. These earlier studies in the 90s were the first to start to report at an epidemiological level that female E4 carriers show an earlier time at which they progress, but also a higher frequency to which they progress. And that is more so than males. And even at the level of if you're a homozygote, so carrying both variants of the allele, or a heterozygote, but even in the homozygotes, women seem to be at much greater risk. And then this study that came out, and I believe Judy Parr is on the call at the moment. She was one of the leaders, the co-first author on this fantastic paper that came out a few years ago, that showed that the rate of progression was at much higher odds for female heterozygotes in between a certain period of life, between 65 and 75 in particular. And the suggestion here would be that there might be, some level of survival issue here, and that this particular age range is where we're really starting to see that sex difference emerge. But the wonderful thing about this study is it took a whole bunch of different studies that were available on the GAIN website, about 50,000 people, and it was able to use meta-analysis techniques to really show this effect. And I think this particular study is very fantastic in its use of big data to try to address these questions. So now we're going to move more into the more funneled section of this triangle, this inverted triangle I'm showing. We're going to talk more about objective phenotyping now. And what I mean by that is we're starting to delve now into what behavioral or objective markers where are we seeing these sex differences at the objective marker level? Specifically, I'm referring to cognition here. I'm going to, again, I think, address the point here that while I'm showing you sex differences here, actually some of the literature doesn't agree, and I will talk about that very briefly. But just for now, I'll focus on the studies that I'm showing here. On the top left is a study by Barnes and colleagues, Lisa Barnes and colleagues in 2005. And what they were looking at was dementia patients. And at the time of death, how much pathology, global AD pathology, did they have in their brain versus how severe was their level of cognitive impairment. This is the level of cognitive impairment as close in time as possible to their post-mortem. And what they found was that women, this dashed line here, women for a similarly high level of global pathology showed much poorer outcomes in their global cognition than males. And the argument there was that for a similar level of high pathological burden, women perform much more poorly. They seem to not be able to withstand the pathology as well. On the right-hand side, up the top here, is an example of a very early piece of work done on this female ApoE interaction to show that women who are carriers, particularly at older ages, seem to show more poor performance on some cognitive measures. Now, this particular paper showed that it was more executive functioning tasks like digit symbol coding that seemed to show this effect. Other measures, say delayed recall of memory, didn't necessarily show the sex effect. And in fact, I do want to also point out, I did sort of address this at the beginning of the slide, but there have been other pieces of work around this time that actually showed the other way around, that male E4 carriers may have shown slightly poorer levels of cognition at a cross-section. So it's important to bear that in mind, that these sort of sex by E4 effects on cognition, particularly a few decades ago, weren't necessarily entirely clear in the literature. Just to point out too that this top row of findings are all cross-sectional. So they're all just taken at a cross-section to see, are there any sex differences? Now, an issue here is that women tend to perform at the baseline, if they're healthy, they tend to perform a lot better than men on quite a few tasks, verbal tasks in particular, but memory-related verbal tasks is where women tend to perform quite well. And in fact, there have been some wonderful findings out from Sunderman and colleagues talking about the idea of norming our cognitive tests more by sex in order to sort of better capture how exactly men and women are performing, because women do tend to have, at the outset, a bit more of an advantage on how they perform. At the bottom here is a finding that I did with my colleagues at the Harvard Aging Brain Study. And what we did was we put 3 different large independent cohorts together. So the Harvard Aging Brain Study, ADNI, and the Australian Imaging Biomarker and Lifestyle Study of Aging. So altogether, we had about 800 healthy people at the baseline. And what I was interested in was, okay, so we've got a lot of information about the cross-section now, but what about over time? Are women showing, are they showing faster rates of cognitive decline than men? Now, if you just look at a simple sex difference on, this is a global cognitive composite, just to alert you to what the B.R.A.I.N is. It's a global cognitive composite. And women in our study, and almost all of the studies that we look at, women perform a lot better than men at the baseline on this B.R.A.I.N composite. But if you looked at simply just a men and women difference, you do not see faster rates of decline between the two groups. It's only when you start to really tease apart the different risk factors that you start to see that women start to show faster rates of cognitive decline. So, for instance, this particular graph is showing that on this red line, this is females who are carriers of ApoE4, and they also have high levels of amyloid burden using PET neuroimaging markers. They're showing faster rates of cognitive decline and much more nonlinear than males who are also carriers and have high levels of amyloid burden. So this is the first sort of work that we had showed that suggested for a given level of pathology or risk, women seem to do more poorly over time, sort of mirroring this sort of the Barnes finding from a while ago. Now we're going to go even further into the funnel, and we're going to look more at neuropathology and biological markers of pathology. First, I'm going to focus on neuropathology and post-mortem work. And there's been 2 big studies that have come out in the past few years that I think that are quite exciting from 2 different cohorts. The first here on the left is from the Mayo cohort, and on the right is from the Rush cohort, the ROSMAP group. And on the left here, what they were doing was looking at simply the frequency, first of all, of autopsy-confirmed Alzheimer's disease. And then they also wanted to look into amyloid plaque load at post-mortem and neurofibrillary tangle density at post-mortem. Remember, these are the 2 hallmark pathologies for Alzheimer's disease dementia. And on the left here, what they were showing was simply in their cohort, they were finding that the frequency of autopsy-confirmed AD in their cohort was showing past the age of 80, that women were showing gradually more and more frequency, and males were dropping off. So it's something to bear in mind. This is not necessarily evidence in the epidemiological side of things, although obviously the Mayo Clinic is more of an epidemiological cohort, but you do need to remember that autopsy studies are somewhat slanted to some extent because of the types of people who decide to have autopsy data released. But what they did show here, this is the same group of people at each of the age ranges, just as you see on the left, as is the same on the right, just vertically. And what they showed was that women across most of the age ranges show far higher or far more neurofibrillary tangle density than men in certain regions of the brain, particularly those regions of the brain that are medial temporal lobe regions. So for instance, here, the CA1 is part of the hippocampal formation, the hippocampus specifically, it's a layer. The subiculum is sort of adjacent to the hippocampus, sort of a gateway component. And you can see in both of these regions specifically, there is a much higher tangle density, particularly at the older ages in women than men. And so that was a very interesting finding to come out. They did not see any sex differences in any of the age bands for amyloid plaque load. So bear that in mind, because that will come back up again later on. Here in the Rush group, they were interested in, again, global AD pathology or amyloid plaques or neurofibrillary tangle differences between men and women. Here they didn't look at age bands, they were just simply interested in the overall sex difference. And they found that the sex difference was apparent in the overall AD pathology load. So amyloid plaques and tangles together combined, it doesn't matter. But where it was really being driven, there was a slight difference between amyloid plaque load, but where they really saw something come out was in the tangle pathology. Women showed far higher levels of tangles, so tau tangles, than males. Now, just to sort of come back to what I'm interested in and where I really focus a lot of my time is in the biomarkers, in vivo biomarkers. Specifically, I tend to look a lot at PET neuroimaging and MRI, although I will show some CSF findings as well. But I want to now focus on where we do and where we don't see sex differences in ostensibly healthy older adults. And this sort of mirrors the neuropathological findings that I showed before. The first piece of evidence that we have is that there doesn't seem to be a sex difference in the level of amyloid burden or in the number of E4 carriers between men and women. So here on the left is the findings that from that same study that I showed you a little while ago that put 3 different cohorts together. That's why you see so many data points for men and women. But what we definitely didn't see was any difference in level of amyloid. This is a global amyloid measure. And on the right here, on the very right-hand side, another box plot that I wanted to show, which is the A4 data that was recently released. Anyone can look at it, similar to ADNI, going online on Loney. And what I did was simply just a sex difference there on all of the A4 phlebotopeer scans that were available. This is in about 4,000 people. And again, there's no there's no sex difference in level of amyloid load. And this is, both of these studies are in people around 70 to 75 years of age who are ostensibly clinically normal. Although in A4, there is a slight higher severity of symptomatology than there would be in the observational cohorts that we see. We also don't tend to see an ApoE4 difference between the sexes. This is not something that I would necessarily be looking for as a biological phenomenon. This is more of a bias thing that I'm interested in. So there shouldn't be a sex difference in ApoE4 levels, but what we're interested in is if there was a sex difference here in the observational cohorts, we would be worried that there may be some kind of bias creeping into our results, but we don't see that, and that comes across the board in a few different cohorts, which is good to see. Now, in terms of in vivo markers with CSF, there has been quite a lot of evidence now that has shown that there's also in CSF a sex difference in the level of tau burden. And this is really driven by those females who carry ApoE4. Now, before I dive into the tau findings, one thing that comes out across the board in the CSF literature in sex differences is there's no amyloid difference. So across the board for CSF amyloid, there doesn't seem to be a sex difference there. So that's important to point out. But what we do see in the CSF literature is that, for instance, this first paper, very early work that came out, was that female E4 carriers seem to show high CSF total tau. And this was, again, replicated in the same study. So this is both ADNI work, showing higher levels of CSF total tau, particularly in females who are E4 carriers, but also have level of cognitive impairment. And this was rounded out by Homan and colleagues, Tim Homan, who did a really fantastic paper doing a very large meta-analysis across I think it was 6 different cohorts, or maybe more, showing that there is a sex by E4 interaction, showing that higher CSF total tau in females who are ApoE4 carriers. And this was across the board, from healthy all the way to a dementia diagnosis, but that this could also be replicated in just those healthy older adults as well. And on the right-hand side here, what we were interested in was looking at changes in CSF. So a lot of people had looked at cross-sectional work all across the board. Here on the other side were just cross-sectional findings, but we're interested in looking at, okay, well, what about change in total tau or p-tau over time? And do you see faster rates of t-tau change in women than men? And what we found was that with women who were ApoE4 carriers, if they had abnormal levels of amyloid load here, they had faster rates of CSF total tau accumulation than males. I notice here that there are some sort of outliers. Even getting rid of those, there was still a difference in the rate of change. And so this sort of led to the idea that, okay, well, it's not just at a cross-section, but we're also able to see these changes over time. Now, why is a change over time important? Well, quite a lot of people, and reviewers in particular I come up against a lot, but a lot of people like to ask me, well, how do you know that what you're seeing is a biological effect versus, say, a survival difference or a recruitment bias? And we're going to thread this theme through a lot of the talk because this sort of relates a little bit to the resilience versus vulnerability argument. The resilience argument is, okay, well, you might see that females or female E4 carriers have higher levels of tau when they're healthy, but could that just mean that the males who could be in that study, who are they can't possibly have that much tau in their CSF, and therefore they've already transitioned to another clinical diagnosis, and so therefore can't be measured, which would suggest, if you pursue that argument, that women are in fact resilient, that they are clinically normal, and yet they still have high levels of CSF tau in their, they have high levels of tau in their CSF. And that argument perhaps could make sense, although Tim Homan's paper shows that, you know, this is across multiple diagnoses that you see this. But one way you could try to get around this issue, trying to assess this issue of is this an issue of progression, is trying to look longitudinally to see, okay, are the rates differing between the two? And there does seem to be evidence of that, at least in CSF, and I'll show you tau in just a second. It doesn't, however, the longitudinal studies don't completely avoid the issue of a recruitment bias. So we need to keep that in mind, that maybe it's simply that we do tend to recruit women who are more indicative of the population, whereas the men who we pull in for these observational studies, that you have to be somewhat squeaky clean. You can't have evidence of past stroke or you know, other sort of neurodegenerative conditions. You can't have evidence of neuropsychiatric conditions, things like that. And maybe that somewhat impacts men more than women for the recruitment into these studies. So it's something to keep in mind when you're looking at this work. So now focusing away from CSF and looking more towards PET neuroimaging. This is where I've really focused a lot of my time and energy lately. And I've been very interested to know where in the brain might women show higher levels of tau. And it's not just where, but do they show higher levels of tau with the tau traces that we have. The tau traces that I'll be referring to today are all flotaucipia, although there is, there are other radio traces out there, and we will be looking at those too. Flotaucipia, is purported to bind to more than neurofibrillary tangle component. And so hopefully this would show that if you're seeing differences between men and women, that you're seeing some level of, AD-related tauopathy difference, although there could be some arguments for morphological differences that may drive these, or partial volume correction, differences that may drive these. And I'd be more than happy to talk about this at the end of the talk if anyone has questions. But let's talk about what the findings are showing. So on the left here, this is a paper that my colleague and I have put together, Matthew Scott and I, and it's currently under review, that is showing just generally across the brain at a vertex-wise level, where do we tend to see sex differences in level of tau burden using flotaucipia. And this is using ADNI and Harvard Aging Brain Study data put together. So it's about 400 clinically normal people. And you can see that there are actually quite a few regions where women show higher levels of tau than men. There's some frontal, there's some lateral occipital, there's lateral temporal, some medial temporal regions. And in fact, if you try to swap this over to where do men show higher tau than women, there's nothing that comes up. This is after correction. But if you correct p-values, FDR correction, for instance, for the males that show higher signal, nothing comes out, which is very interesting. This has been replicated or has been published before us, which is really nice, by B.R.A.I.N and colleagues, showing that similar regions are coming out in terms of regions of interest, so anterior frontal, lateral temporal parietal, that are showing a higher female burden than males. And these are just general sex differences. These are not sex differences in combination with amyloid or with E4. But what we have done with our findings is we've tried to also look at, well, what might be sex by E4 and sex by amyloid impacts. And on the right here is a paper we published a little while ago, showing that if men and women have a similarly high level of amyloid burden, this is HABS data at the top and ADNI data at the bottom, that women tend to show higher levels of entorhinal tau than males, suggesting that there does seem to be sort of a two-hit component here, that being female, but also having a higher level of amyloid burden, there seems to be this extra vulnerability or susceptibility to higher levels of tau. Now, while I say that there is this higher vulnerability or susceptibility, just keep in the back of your mind this idea of resilience. It could also be, because this is all cross-sectional, of healthy people, this could also be an argument for resilience, that women were able to hold on for a little bit longer in their level of being healthy and being able to hold on to having a little bit more tau in their brain for a given level of amyloid. So we can't discount that argument, but suffice to say, there seems to be something there. What I'm not showing you here is the sex by E4 effects. And the interesting thing with the tau data that we've been conducting so far in PET, that we don't seem to see the same sex by E4 effects that have been reported in the CSF literature and in the neuropathology and the progression literature. Now, there's a couple of reasons for why this might be. One could be statistical power. We just don't have as much tau PET data potentially to see these effects. The other issue could just simply also be that the modalities are showing slightly different stages of the disease, with CSF showing slightly earlier or different states and phases of the disease. Also, I really wanted to point out, this is where I'm getting really excited, because remember the arguments that I was saying about longitudinal, looking at longitudinal data, not just cross-sectional. And this is very hot off the press data that we are showing at AAIC this year as a poster. But I would also like to refer you to a talk by Ruben Smith, the BioFinder study in Sweden. They will be showing their work that they also showed at HAI in a poster this year that's very exciting, and I'm looking forward to seeing the talk, that's also showing a higher rate of tau accumulation in females than males in the BioFinder tau PET as well. But here, what we were interested in looking at was not just simply a rate of change in just tau. I was interested to see, for a given rate of accumulation in amyloid, so this down the bottom here is over time in amyloid. You can see there's like 1 or 2 scans at least for each person. For a given rate of accumulation in amyloid, is there also faster accumulation of inferior temporal tau, for instance, in women than men? And what you can see here is most people, are sort of normal. These are all people who are clinically normal at the outset of the study. And you can see there's a range of levels of amyloid and tau at the baseline. But that women seem to be showing this faster rate of accumulation for at the higher levels of amyloid load. And this seems to be the case with those people who seem to be showing slightly faster rates of amyloid accumulation as well. Mind you, I need to be very careful with this finding because it's still very early days. As you can see, there's not a huge amount of data yet. There seems to be a lot of data at the cross-section. But in terms of longitudinally, most people only have 2 tau PET scans. This is Harvard Aging Brain Study. So we have some of the greatest amount of tau PET imaging over time. So we're very lucky there, but I'm still going to be very conservative about this. And I really, really want to sort of hold out to see once pandemic time allows us to do more PET imaging, I'm hoping to sort of really tease us apart once we've got more people with 3 time points of data. As you can see, there's a bit of noise over time. So we just want to get to the bottom of that. But the interesting thing here is I can also replicate this with ADNI data. ADNI has way less data than we have, but there seems to be something coming out there. Finally, we've also got a poster session that's also showing that for a given level of tau burden in women, there seems to be faster cortical thinning in similar regions. So I think that's a nice piece of evidence too to refer to. Now, what's the animal literature showing about all this? And I think that the AD mouse models are particularly fascinating because they, to some extent, show similar pathology to what we are trying to mirror in our sporadic AD, although obviously in a very different way and in some cases to a much more severe extent and in a much shorter time frame. But the unintentional findings from the animal mouse models is that almost all of them show quite striking sex differences, particularly with regard to tauopathy. So just to be clear, that a lot of these mouse models actually also show faster rates of accumulation in amyloid. Oh, I believe I have a question. Oh, yes. So a really great question from someone just asking about, is faster rate of accumulation in tau also associated with faster cognitive decline? And actually, I'll show you some data about this in a second, not in terms of slopes on slopes. So, and I won't be showing you this, but I can talk about it later. But if you're looking at slopes in tau and slopes in cognition, there doesn't seem to be a stronger association in women than men. But for women who have higher levels of tau, their rates of cognitive decline are much faster than males who also have higher levels of tau. And I'll show you that in just a second. So thank you for that question. So here, what you're seeing is that in this particular paper, they do show that higher area of amyloid, so the amount of amyloid across different regions that they assayed, there was higher levels of amyloid in this particular mouse model. But in fact, what was the most striking was the amount of hyperphosphorylated tau that they found. And that was very, very striking difference, not just in the cell numbers, but also in the percentage area across the regions that they were looking at, particularly the CA1 region. On the right-hand side here, this is the tauopathy mouse model. And they found that the pathological features were very pronounced in the female mice, particularly in the hippocampus, but also across the cortical regions. But they also found that there was more severe synaptopathy. So they were also looking at measures of synaptic death and degeneration, and that females really did show much greater susceptibility to this in those female mouse models that were showing a lot higher levels of tau. So this is something to bear in mind, that mouse models are also showing this. And actually, just going back to this, both of these studies, they don't directly examine estrogen, but both studies in their interpretation of this data suggest that, because it's actually at the point at which the female mouse model starts to show a very declining level of estrogen. So it's later in the mouse life that these findings seem to come out. It's around the time when estrogen levels start to significantly drop in the mouse model. So they argue that this may be a contributor, and we'll discuss this in just a second. Just coming back to the question in the chat box. What we have shown, and I haven't shown it here, but please do come to my poster, because I talk about slope on slope. But what we see here is that for a higher level of cross-sectional IT tau, this is cross-sectional baseline tau, women show faster rates, not baseline, because tau comes in the middle of our study, actually. So the baseline is actually in the middle of the study. And what we do is we model negative time to positive time. And what you can see here is that women really do show this faster rate of decline than men. And in fact, men almost seem like they're not moving at all for a higher level of tau, which seems very odd, considering that tau is so proximal to cognitive performance, which again highlights this question of, to what extent are these males in these studies particularly hardy, particularly healthy? And to what extent is it that women here are actually showing a form of either resilience, or are they actually showing the normal rate of what we would consider to be decline, and the men here are the survivors? So it's something to keep in mind. I like to always sprinkle my talks with these questions, because I think that that is an important thing to bear in mind. Another finding that came out a few years ago also looked at sort of multiple, so a ratio of total tau to amyloid load, and basically showed that ADAS-Cog performance over time showed a greater increase, a greater rate of poorer performance, so a higher score is poorer performance on the ADAS-Cog in MCI females. So on the left here, I'm showing clinically normal or healthy older adults, but on the right here, these are women who are already showing mild cognitive impairment, and men. And this might there's some piece of evidence that maybe it's not just a survival effect that I'm showing, that in fact, even in those with mild cognitive impairment, women seem to be showing poorer performance over time for those who have much greater or much more abnormal markers of AD biomarkers in CSF. So what then do we have as pieces of evidence that might have a stronger sway for resilience versus vulnerability in women? Now, there have been some studies that have come out, and in fact, I've reviewed a couple. I can't go into detail, obviously, but I've reviewed a couple of pieces of evidence as well recently that have been very interesting, that suggest that maybe females might have a protective effect, particularly against tau-associated neurodegeneration. So, for instance, this is Osenkopoula's work, Rick Osenkopoula, who published earlier this year in JAMA Neurology, looking at a measure of what they refer to as brain resilience and cognitive resilience. Now, this is not brain resilience in a very sort of general sense, but rather resilience to tauopathy. And the brain resilience was a measure of cortical thickness, residualizing out level of tau burden on PET. So if you had a positive number, that meant your thickness was greater than what we would expect for your level of tau burden, and the negative number meaning the opposite. On the cognitive resilience side, they had a few different measures of cognition, one of them being MMSE, which is being shown here, residualizing out the level of tau burden. And what you can see here is the associations of age in different regions of interest with each of these resilience markers. Now, across the board, the cognitive resilience marker didn't really show a huge amount here, but on the brain resilience side, it seemed to show that women showed actually a slightly more protective effect. So they seem to show higher levels of cortical thickness or juiciness in comparison to their level of tau burden in comparison to males. And then down the bottom here, this is not just found in the Mayo group. This is Clifford Jack's work from a few years ago. But women seem to show much larger hippocampal volume than males. But even if they are E4 carriers, they seem to show larger hippocampal volume across age. And this is not just a finding in Mayo, that it's also been shown in BLSA, the Baltimore Longitudinal Study of Aging. We see hints of that. ADNI also shows hints of that. So there's some evidence to suggest that there may actually be some level of resilience in terms, well, at least in terms of the volumetric morphological downstream effects from the tauopathy, which is very interesting and needs to be looked into further and what that might be. And I've sort of touched a lot onto this survival and maintenance idea, but just to again reiterate, we still can't directly answer a lot of these questions of, is it the women are surviving longer with tau in their brain and they're able to hold it for longer, and the faster rates of decline are simply showing that, well, eventually they've got to meet up with the men and we're just simply seeing that now? Or is it this idea of maintenance? Are they able to hold pathology for long periods of time? The men have already moved on, that's the survival argument, but women can just hold on to it for longer. And so I think it's important to keep these aspects, these arguments in mind. But now I want to touch on potential biological mechanisms. And I'll try to be very brief on this because I know I'm taking up a lot of time. Sex hormones has been talked about quite a lot in the literature as a suggested rationale. There's not a huge amount of evidence in terms of sex hormones and tau burden in human literature. On the left-hand side, this is the first study I've seen so far of tau burden in terms of tau PET. This is hormone therapy. What they found was that females who take hormone therapy look a lot closer to their male counterparts in terms of tau burden. They show somewhat similar levels. It's the women who don't take hormone therapy that show much higher levels of tau burden than men. This is early work, preliminary findings, but still very interesting. This work that came out, Rahman and colleagues, this is Lisa Mosconi's lab, that came out in neurology this year, showing that menopause seems to be associated with, this is self-reported menopause symptoms, seems to be associated with different amyloid, FDG, and white matter hyperintensity markers, suggesting that there might be an association there. Then there's also genetic vulnerabilities beyond ApoE that's being looked at as well. So this is Tim Homan's lab that was looking at sex stratified GWAS results for CSF total tau. So they were trying to determine whether there were novel loci that would highlight differences between men and women for levels of CSF total tau. And they did find one particular loci that seemed to code for the gene expression was associated OSTN and CLDN. To some extent, there seems to be some hormone-related pathways, particularly with OSTN here, and that neurofibrillary tangle burden was associated more strongly with females to do with this OSTN expression in the prefrontal cortex in males, and also with CLDN16. I would strongly recommend looking at this paper. It's quite interesting. It's just this idea of trying to determine whether these sex differences can really show us what might be explaining the potential biological pathways that might drive these differences in tau levels. And then by the same group, a year later, another fantastic paper that looked at now, instead of trying to tap into CSF total tau, but now in terms of neurofibrillary tangles in post-mortem work. And very interestingly, they found different loci. They were not able to replicate the loci that they found, the locus that they found in the CSF total tau. They found something slightly different. It was actually a protective factor for males. So this particular SNP that they found, the minor allele was associated with lower neurofibrillary tangle pathology in males. Now, the argument for why these two might show slightly different findings is somewhat complicated, but one thing that they did suggest is that they might be tapping into slightly different things. In fact, Tim Homan's meta-analysis that I referred to earlier on, they actually looked at post-mortem work, not just CSF total tau to look at sex by E4 differences. The post-mortem work did not show the same results as the CSF findings. And so I think there's some interesting nuances there that we need to bear in mind. It's just very similar to the CSF and PET dissimilarities that I'm seeing as well. So it's something to bear in mind. There's also some arguments about vascular contributions. Women and men do display differences in terms of their vascular risk, the expression of their vascular risk. Women tend to show more small vessel disease. Men tend to show more large vessel disease. And so maybe there could be some sort of impact there. There's a poster that will be shown this year at AAIC that I think that you should see. It's not mine or my group's work, so I don't know what it will show, but it's looking at Framingham Heart study information with tau PET. What they're showing is that high risk males for CV risk show higher level of tau PET signal than lower than the low risk, but the women don't seem to show this vascular impact. So that's important to think about. On the other side, here we have Paula Gilzan's work. They're based in California, that looked at thousands and thousands of people in terms of early adulthood hypertension, and found that women who had early levels of hypertension around the time of menopause actually showed higher increased risk for progression to AD dementia than men. So there seems to be potentially a vascular component there. Something else that I'm very intrigued by, and I'm feeling quite I'm feeling that there's probably a lot here that we need to unpack over time. But this is mouse model data looking at immune pathways. What we do know, and this has been found for a long time, this is not AD related necessarily, but that adult microglia or just microglia across the lifespan shows a sex dimorphism. And you can see that here in Kodama's paper, that there's definitely a difference in the gene expression that comes out from adult microglia, but this is across the developmental lifespan. But that in fact, male and female microglia express different microRNAs in relation to tauopathy. And one argument is that women have more of a homeostasis with microglia than men. So men have a very pronounced response to tauopathy with their microglia, but the women may not. And one argument, particularly from this paper, was that maybe women take longer period of time with the microglial activation to a level of tau burden than men do. And maybe this might be why they may not attack, or they may not have as strong immune response to the amyloid and tau burden in their brain. It's something very fascinating. It's still early work, but something I think we all should pay attention to. And with that, I will just finish off with a general summary. The idea being that we don't necessarily see sex differences in amyloid load or amyloid accumulation, although I might just quickly alert people to the fact that Lisa Mosconi's work does tend to show a little bit of an amyloid difference at the menopause age. But that higher tau levels in women definitely seem to be coming out in comparison to men across the board, CSF, tau PET, and postmortem. and that this is leading to faster rates of cognitive decline. But what this might mean in terms of resilience and vulnerability, we still need to try to get to the bottom of it. There's some reviews here I strongly recommend having a look through. If you would like copies of those, please let me know. And I'd like to end off by saying a huge thank you to my lab on the right-hand side here. These are some of the most amazing people ever. And if you're ever interested in working with us, I actually am interested in looking for a postdoc over the next 6 to 12 months. So if you are looking, please do get in contact with me. You can find me on Twitter here, but I would like to also very much say a huge thank you to my beautiful girls. They're 18 months now, Isla and Vanessa, and they've really been a huge inspiration for all this work, and my funding sources that have kept me doing the science that I love. So thank you very much, and I will now take any questions that people might have.
Thank you very much, Rachel. This was excellent. It was really fantastic to see this journey from epidemiological findings all the way to potential biological mechanisms.
Thank you.
Other questions? So don't be shy, please go ahead.
Hi, this is Judy Pye. I have a question for Rachel.
Hi, Judy.
Can you hear me okay?
Yes.
Hi, how are you? It's so
I'm
good to
very
see
well.
you and your
Lovely.
girls.
I'm so grateful that you spent some time to listen to this talk. I really appreciate it.
Thanks, Rachel. I really enjoyed it. It was a very beautiful summary. So I did have a question. You really laid out some nice work, including your own, on the pathological sex differences, and that they may lie more with tau pathology than with amyloid pathology. And like you mentioned, this follows really nice other biomarker data, such as neurodegeneration with volume loss or cortical thickness or thinning. We see those patterns as well. I wanted to get your insight. Do you think that this is a function of the timing of changes with respect to AD pathophysiology? So we see this more in MCI than in cognitively normal individuals. Is this specifically tied to some underlying biology, or does it perhaps also relate to what you showed with epi data, such that women and men tend to diverge a little bit later in life with respect to conversion and onset of symptoms? So in other words, I'm just trying to unpack a bit why we don't see as much of differences with amyloid than we do with tau, and if it has to do at all with when it's occurring in the pathophysiology.
Yeah, you know, I'm going to start out by saying it's such a complicated question, and it's such this question is exactly what goes through my mind, and I have so many different thoughts that are all sort of buzzing. Because I guess my first answer would be I don't know, and that's not because I'm not thinking about it. It's more because I don't think I have a clear answer on that. I have lots of pieces of evidence, and I'm not sure how they all fit together. So, you know, the Lisa Mosconi work and the work that has been looking at, for instance, the ELITE trial on early versus late menopause, so hormone therapy introduction, suggests that there are amyloid load differences and these are women who are, you know, 50s, 60s, so much earlier, and they seem to be showing a higher level of amyloid burden in those who either had early menopause or have higher symptomatology for menopause, suggesting that maybe in this early stage there is something there. I'm a little bit, I'm still wanting to watch that space though, because we know that, for instance, PET imaging in particular is quite noisy at that age when the radio tracer, the signal to noise ratio is a lot hard. It's a lot more of a balance there. So I think we need more data to really sort of target that question, but there seems to be that potential. So in terms of timing, there might be something there. And we're going to be delving into that a little bit with the Framingham data too soon. But then in terms of the cascade of events, if we put that evidence aside for a second and just say, okay, there doesn't seem to be an amyloid difference, at least in the older adults, but that tau, neurodegeneration, we see that there's higher rates of progression, so it's downstream things, then yeah, I do think there's a timing component to this. But if we try to determine then what could be the driving force of that, why is the timing so important? It could be a few different things, right? Then maybe it's not the menopause idea necessarily, because menopause occurs so early, but maybe it's the downstream impacts or the long-term impacts of the lack of estrogen over time, or maybe it's the gene expression components that are triggered. So the issues of greater tau burden are coming out from the gene expression, but only once you have some of these markers, so genetic risk already from ApoE, or some issue with amyloid load, or there could be, you know, a metabolic risk issue. So I do think timing is important. I just don't have an answer yet of what exactly that is. And I think that's what you and I, that's the whole purpose of us being here right now, is our interest in that, I would say. It's a great question.
Yeah, thanks, Rachel. I think a lot of your longitudinal work is going to really elucidate that, and being able to aggregate bigger data sets so we can look at these specific age bins, similar to what we've done with GAIN in the past.
Exactly, exactly. And that's why I'm really interested. Actually, what I'm really interested in doing is for you and Tim and I to knock our heads together and start to really put some data sets together and tackle some of these more tricky questions that really require a lot of power.
Yeah. Thanks, Rachel.
Yeah, no, thank you. I think we had a couple of other questions on the chat. Do you think there might be a tighter association in GWAS or other findings between CSF tau and neuropath if we look specifically at CSF p-tau rather than t-tau? Very good question. T-tau could be picking on some of those things that other neurodegenerative processes. And yeah, sorry, that's a really good point because I didn't highlight that. And there is a difference, arguably, between CSF p-tau and total tau. And in fact, there's been some beautiful papers lately on phospho-tau, both in bloods and CSF, and different types of p-tau isoforms. And yeah, there could be that indication. I'm not sure why the Homan paper focused on total tau specifically. Maybe someone in the lab is on the line who can answer that. My feeling is maybe it was because there was more data there available, so they could put all, you need as much data as possible for these huge GWAS studies, and maybe the summary data that they had was only available for t-tau. But that is a potential possibility that maybe it was tapping into the t-tau findings were tapping into more of that broader aspect of neurodegeneration than necessarily the phospho-tau AD associated component. So yeah, good question. And then an association, is it possible that the greater tau accumulation in females leads to faster desynchronization in large-scale brain areas in the cognitive processing? Yeah, look, that's a really interesting question. I think that's quite a nuanced point, and I don't know if we're necessarily at I haven't really looked into that necessarily in terms of like tau accumulation in certain regions having impacts on sort of large-scale cognitive domain breakdown. That's definitely something that we could look into. It's a really good question. And Carol, hi Carol, it's great to see you online. Can you talk more about sex differences in tau propagation throughout the brain and what might be driving that? Yeah, so good question, because in our latest paper that we have under review, and hopefully it'll be out sometime if all the reviewer gods align, basically we're showing that women show higher levels of tau burden in certain areas of, so if it's AD related, so if we're looking at amyloid associated tau differences between men and women, we're seeing it largely in the medial temporal lobe or the temporal lobe. But if we just look at sex differences across the board, you see it in quite a few different regions of the brain, frontal, occipital, things like that. My initial thought was actually that it was noise. But I've been starting to really look into this more and more, and I'm starting to become more taken with the idea that maybe it's not. And what I mean by that is, we've started to look into meningeal binding, so off-target binding. We've started looking at skull binding in signal because we know that there's not a huge amount of meningeal binding with flutalsapine PET, but there could be that potential. And we have shown that women do tend to show higher skull flothousapia PET signal than men. And that's in lots of studies, not just ours. And in fact, University of Pittsburgh alerted me to this at HAI, and I'm forgetting the researcher's name, I do apologize. But he alerted me to this early on. And so we started really looking into it, but that doesn't seem to be impacting these findings. The other thing is, could partial volume effects be a problem? So we've looked at partial volume and corrected and non-partial volume corrected. Obviously in the, we're not seeing necessarily that that's having an impact, but what we're starting to do now is simulation studies to see, okay, if we do partial volume correction on men and women, if we give everyone the same number and just run partial volume correction, are there warping effects in men and women? And there are some, but they're not in the regions that we're seeing tau PET signal differences, which is very largely not seeing that. And so we still need to get to the bottom of this. I don't know if we do assume it's a biological effect. I don't know what the tau propagation differences might be, but some of the stuff that I am interested in at the moment is, I don't know if you guys saw Simon Dujardin's paper that came out maybe a month or two ago on tau seeding, tau seeding. And there seems to be that some people seed differently in their tau levels. And I would be very curious to see if there's sex differences there. So thank you so much for that question. And then another question was, two questions. Do you know if sex differences are observed? Yes, across things like Lewy body dementia, frontotemporal dementia. Actually, I was just in a talk yesterday where somebody said, I'm looking at frontotemporal dementia and I see sex differences, so that I think it was the direction of men showing higher rates of frontotemporal dementia in their study. Now, again, I don't know which study that was from, but there doesn't seem to be a lot of literature out there at this stage. It could be that there's no literature there because people have looked at it and not seen anything and not published it, or that it's something that we need to look into further. I think AD dementia gets a lot of radio play, and maybe we need to really widen the scope and look at other dementias, but I don't know beyond that. So somebody else may be able to jump on and say. And what about our other tauopathies? This is exactly what I'm interested in. So we know things like, now I'm gonna have to be a little bit careful here. What we do know is that we see differences in tau levels. It could be it's largely p-tau or flothousapia. That is a particular tauopathy. And we know that other tauopathies have different expressions of tau. There are lots of different expressions of tau, other tau species. And so it is unclear to what extent this is an overall tau umbrella problem, or is it this specific type of tau seeding and tau species. Watch this space, I suppose. But if anyone wants to join in with me and write a huge grant on that, let me know. I'd love to do that. And with that, I think those are all the questions that I had on the chat. Are there any others that I can answer?
Yeah, so last chance. We're a little bit over time already, but please go ahead if you have a compelling question.
Sorry, Michael. I knew I would go over time. I apologize.
Well, thank you very much. So there were already a lot of questions, which really reflects the huge interest in your work. So keep it up.
Thank you.
Thank you everyone for listening. So next week we'll have actually a little break because there's the AAIC. So we'll all be busy looking at a lot of virtual lectures anyways. Then early August, there's another talk by Kathleen Casaletto. And then, so that's basically the last talk before the summer break, and we will resume then in September. So thank you very much, Rachel, again. That was really great. It was fun. And yeah, see you all next time again. Bye.
Thanks very much, everyone. Bye.